Welcome everyone to my presentation on long-term respiratory health outcomes in children exposed to PAHs prenatally in the United States. My name is Victoria Alarcon, and this is for PH161. The striking image you see shows a silhouette with lungs against an urban backdrop, which perfectly captures our topic: how urban air pollution affects the developing respiratory systems of children before they're even born. Let's start with some basic facts about PAHs. They are harmful pollutants that come from combustion processes. The major sources you encounter daily include vehicle emissions, industrial pollution, and tobacco smoke. What makes this particularly concerning for pregnant women is that PAHs enter the body through inhalation of air particles. As shown in our diagram, these particles travel from the air into the lungs, enter the bloodstream, and can cross the placental barrier during pregnancy. This exposure directly harms fetal development, increasing respiratory risks that persist throughout childhood and into adulthood. The scope of this problem is significant. PAHs are not just pollutants, they're carcinogenic, mutagenic, and developmental toxins. Beyond vehicle exhaust and industrial pollution, smoking is another major source of exposure for pregnant women. When PAHs cross the placenta, they specifically harm fetal lung development, leading to chronic respiratory issues like asthma. What makes this a public health crisis is that low-income communities face the highest exposure risk, creating a cycle of environmental injustice. Now let's examine how PAHs actually damage the respiratory system. The complex diagram you see illustrates the cellular level mechanisms. PAHs induce oxidative stress, which directly damages lung cells. This triggers inflammation that leads to airway remodeling. Essentially, the airways become permanently altered. PAHs also cause epigenetic changes that affect how lung cells differentiate and develop. A key pathway involves AHR activation, which disrupts normal lung cell growth. Research has consistently shown that this translates to reduced lung function, with asthma and wheezing being the most common long-term effects. The health consequences of prenatal PAH exposure are both immediate and long-lasting. Initially, we see prenatal PAH exposure causing low birth weight and increasing the risk of developmental delays. The respiratory issues that develop include asthma and wheezing, which are among the most common problems. More severely, PAH exposure can lead to chronic obstructive pulmonary disease later in life. Children with prenatal exposure are also more susceptible to frequent lower respiratory infections like pneumonia and bronchitis. Importantly, research shows gender differences in susceptibility, with female children showing stronger associations with asthma after exposure to certain PAH metabolites. Understanding why fetuses are so vulnerable requires looking at their biology. Fetal detoxification systems are immature and simply cannot handle toxic exposures the way adult systems can. This diagram shows how PAHs enter our environment through various pathways. PAHs disrupt lung development through oxidative stress and also impair immune system function. At the cellular level, cytochrome P450 enzyme activation generates reactive oxygen species, or ROS, that damage cells. Perhaps most concerning are the DNA methylation changes that lead to abnormal gene expression. These epigenetic changes can have lifelong effects. Additionally, PAHs affect placental function, reducing the efficiency of nutrient and oxygen transfer to the developing fetus. Environmental health is fundamentally an issue of environmental justice. Low-income urban communities experience disproportionately high PAH exposure. Minority populations, particularly African Americans and Hispanics, are at greater risk of health impacts. This isn't random, it's because these communities often live in proximity to industrial sites and major highways, where exposure levels are highest. Urban areas naturally experience higher PAH concentrations due to traffic density and industrial activity. What makes this worse is that limited healthcare access in these communities worsens health disparities, creating a cycle where those most exposed have the least access to treatment. We have compelling real-world evidence of the PAH respiratory health connection. When the Utah Valley Steel Mill shut down, researchers documented improved respiratory health in the surrounding community. Similarly, during the 2008 Beijing Olympics, when pollution was temporarily reduced, there were measurable health benefits. One important study of 1,081 births found interesting sex differences in how PAHs affect children. Interestingly, this study found only limited association between PAH exposure and asthma overall, reminding us that the science is still evolving. However, the evidence consistently supports the need for pollution reduction policies, and real-world data continues to confirm the link between PAH exposure and lung disease. Addressing this crisis requires comprehensive policy action. The Clean Air Act has already reduced some pollutant emissions, but much more is needed to protect vulnerable populations. This diagram shows various air pollution reduction strategies, including urban planning approaches. We need enhanced air quality monitoring in high-risk areas, and urban planning should prioritize increasing green spaces, which act as natural air filters. Traffic emissions must be reduced through better transportation planning, and we need to accelerate the transition to clean energy solutions to lower overall PAH emissions. This diagram shows how proper urban planning can incorporate vegetation, wind corridors, and sound barriers to reduce exposure. While we know much about PAH effects, significant research gaps remain. We need more longitudinal studies that follow children from prenatal exposure through adulthood to fully understand long-term effects. The causal relationships between PAH exposure and specific health outcomes need further investigation, and we need to better understand dose-response relationships. How much exposure causes what level of damage? From a practical standpoint, developing prenatal screening programs could help identify at-risk children early. Community-based interventions are vital for reducing exposure at the local level. And we need targeted protection strategies specifically designed for vulnerable populations. Let me summarize the key findings. Prenatal PAH exposure unequivocally leads to significant respiratory problems that persist throughout life. The damage occurs through oxidative stress, inflammation, and epigenetic changes that fundamentally alter lung development. Asthma, bronchitis, and COPD are common long-term outcomes that we can directly trace to early exposure. Vulnerable populations, particularly low-income and minority communities, face the highest exposure risks and the most severe health consequences. This demands immediate action. We need stricter policies to reduce PAH exposure at the source. Most importantly, early interventions can prevent these long-term health issues, making this both a public health imperative and a moral obligation. Thank you.